All right, so today we're going to be talking about some applications for quadratic equations. And this may seem a little bit familiar, so it's a little bit of a review of some things that we've already talked about, but we're going to spend a little more time to get a little more practice before we move on to something new. And so this week we are talking about something called projectile motion. It's one of the most common applications of quadratic functions. And so what that is it's when an object is thrown into the air or shot into the air, the movement of that object is projectile motion. And so we can model that with parabolas. And so when we do that, the equations that we get, we often call them h of t. And so that's function notation, which we talked about at the beginning of the year. Those were the problems that looked like f of x equals whatever. But these we call them h of t because they are height as a function of time. And so what they're telling us is how high an object is based off of the amount of time since it was thrown or shot into the air. And so something that you're going to want to know is that even if an object is shot perfectly straight up into the air, when we graph it, it's going to still look like a parabola because our x-axis represents time. It measures time, and time is always moving forward. Even right now, as I'm watching the ticker on my video counter move, I'm watching time move forward. And so when we graph it, we'll still see those parabolas that we're used to seeing. So every object in projectile motion has something in common, and that's gravity. Gravity is acting upon anything that we throw into the air as long as you're on the planet Earth. And so we'll notice a lot of similarities in these equations with the way they are set up. Specifically, you'll notice that the leading coefficient, the a value that's in front of our x squared, will usually be negative 16 or negative 4.9 because those are the constants for gravity. And so if you know anything about physics, those numbers look familiar to you because gravity is negative 16 feet per second squared. If we're talking about feet, or it's negative 4.9 meters per second squared when we're talking about meters. So here's our first example. It says some fireworks are fired vertically into the air from the ground at an initial speed of 80 feet per second. The function for this object's height, h of t, at time t seconds after launch is h of t equals negative 16 t squared plus 80t. How long will it take the fireworks to reach the ground? So that's a lot of fancy words to say this. Maybe it's the 4th of July and we're celebrating with fireworks. We can track that firework. We can know how high that firework is in the air by using this equation, h of t, so the height based on the time of that firework is equal to negative 16 t squared plus 80t. Now the question that it's asking us is how long will it take the fireworks to reach the ground, right? So we're talking about some debris from the firework falling back to the Earth's surface. And so to get an idea of what's happening, I'm going to draw a picture. So I'm going to flip over to a whiteboard here, and I'm going to draw a graph. And you can get a nice, pretty graph using the equation in your calculator. You're going to have to change the window to fit the big numbers, but I'm just going to draw a good sketch because I have an idea of what's happening in this problem. So my y-axis, the h-axis, and my x-axis, or my t-axis in this case. Right, so it's not really y. I shouldn't have said that. And I'll use the color red to talk about the firework. So let's think about this. Before the firework launches into the air, so we call that time 0, the height of that firework is 0 feet in the air. So what that means is that at the very beginning of this problem, my firework is right here at the origin. Time is 0, the height is 0, and so there's my firework. Well, I light the fuse and I run away, and that firework shoots into the air. Well, the one thing that I know for certain, because I live on Earth, is that what goes up must come down. And so it looks like that. And so again, your calculator will draw a much nicer, prettier picture for you. But I know that I have something like this happening. And the question wants to know, where am I going to hit this spot? How long will it take for me to get here? And I'm going to use a feature about parabolas that we've talked a little bit about, but haven't spent a whole lot of time on. And that's the fact that parabolas are symmetrical. And so we have this thing called the axis of symmetry. And you should be very familiar with that by now. But the axis of symmetry is that invisible line that cuts the parabola in half. Now, because I'm not a great artist, it's hard to tell. But what I do know is that because this is what cuts the parabola in half, I'm actually going to have the same amount of distance from here, the starting point, until I get to the axis of symmetry, that halfway point, as I am going to have over here, the axis of symmetry all the way to the landing spot. And so if I know that that axis of symmetry is halfway through, then I need to find the axis of symmetry to figure out how long it's going to take for me to get halfway through this. And so there's a formula for that, if you remember. The axis of symmetry can be found using the equation x equals negative b divided by 2a. That's not a great b, so let me try and make it look a little bit better. Negative b divided by 2a. Well, those numbers, the b and the a, come from the equation that was given to us in the problem. And so the equation said h of t equals negative 16 t squared plus 80 t. And what I know is that a is always the number in front of x squared, or t squared in this case. So my a is negative 16. And my b is always the number in front of t. And so my b is 80 in this case. And so now I'm going to plug those numbers in to this formula. And here's what it's going to give me. X is equal to, or really in this case t, because we're not using x, we're using t to represent time. The time that it takes to get from the starting point to the axis of symmetry is equal to negative b, which is negative of 80, plugging that in, so I'm using some parentheses, divided by 2 times a, which is negative 16. Now you can put that in your calculator. We'll do a little bit of reduction here. That's going to give me negative 80 divided by negative 32. A negative divided by a negative is always a positive, which is a good thing because time can never be negative. And if you put this into your calculator, what you're going to see is it reduces down to 5 over 2, which means it takes about 2.5 seconds. Let me write it as 5 over 2. It's going to take 2.5 seconds from the time the firework is shot into the air until it gets to this point right here, its maximum point at the axis of symmetry. Well, if I know that it takes 5.5 seconds, or 2.5 seconds, to get from this spot here, or to make it this distance, I should say, this whole distance, well, then I know it's going to take another 2.5 seconds to travel this whole distance here. So what I can do now is I can multiply that by 2, and I'll end up with the fact that it takes 5 seconds for that firework to come back to the ground. Right, so the question asks, how long is it going to take? It's going to take 5 seconds. So that's one of the ways that I can ask questions about these, is I can say, how long will it be until it comes back to the ground? Example 2 says the Apollo's Chariot, a roller coaster at Busch Gardens, moves at 110 feet per second. The function of the ride can be represented by h of t equals negative 16t squared plus 101t plus 10. What is the maximum height reached by this ride? And so, again, what I want to know is, what is the maximum height? How high is this ride going to go? And to figure that out, I'll draw another graph. So let me see if I can quickly erase all this. And draw another graph. And so once we graph it, we're going to get something that looks like this. And this time I don't care about where it's going to end up. I want to know what the maximum height is. And so by looking at this parabola, I can see visually that the maximum height is going to be up here. Well, to find that, I use my formula again to find the axis of symmetry. And then I'm going to plug that number into my original equation to figure out what it's going to be. And so this time, using the equation that was given, h of t equals negative 16t squared plus 101t plus 10, I'm going to plug into my axis of symmetry formula. And that's going to give me t equals negative b. Well, this time b is 101 because it's the number in front of t. So the negative of 101 divided by 2a. And again, a is negative 16. So that's going to give me negative 101 divided by negative 32. And again, you can plug that into your calculator, use alpha y equals, and it'll give you a nice simplified fraction. But it doesn't simplify. And so this time we end up with 101 over 32. And that's how long it takes to get from our starting point to the axis of symmetry. Right? So, but that's not what the question's asking. It's saying, how high is it? And so now I'm going to take this 101 over 32, and I'm going to plug it in everywhere I see a t, right? Because I know how long it took to get to that line. And so now I want to figure out how high it is. And so I have h of t equals negative 16, and I've come to a t, so I'll plug it in with parentheses, 101 over 32 squared plus 101 times 101 over 32. And so I'm using the different colors. Hopefully you see where those are coming from. Plus 10. Now don't do that by hand. Plug that into a calculator and you're going to get h of t equals 857 feet. So I'm going to leave question 3 for you to have an opportunity to try one on your own. The solutions are posted in that module on Canvas, so you can go and look at that and check to see if you got it right. This was just a quick tutorial, so if you have questions, please feel free to email me, and we can set up a Teams meeting. All right, I miss you guys. Be safe, and I'll talk to you later.